We start with a company called AMBOSS. AMBOSS is a leading provider for medical information based in Germany and the US, used by students and professionals. And they face a problem, I think, that we all, to some degree, have faced in the past, learning from user interactions about your search quality. And that problem has become even more difficult recently in the times of generative AI, RAG systems, where users don't really interact with search results directly anymore by clicking, but they consume the content by chat interactions and things like that, and analyzing that information is an interesting challenge. Yeah, with that introduction, over to you, Valentin.
Thank you very much. Let's see. Super. Thank you very much for, good to see you all. Thank you very much for coming and showing up instead of taking an espresso down the street somewhere. I hope you had a good lunch. My name is Valentin von Seggern, and I'm a product manager in a company called AMBOSS. Has anyone here ever heard of AMBOSS? Yes, it's a trick question. The company exists. But let me just for context, so you know what kind of thing I'm talking about. So we are a software as a service, subscription-based business model for medical students and resident physicians to study for the USMLE, the US Medical Licensing Exam, and other licensing exams around the world, and also used as a reference during patient care by medical professionals. We are roughly 500 people in New York, Berlin, Cologne, and there's a small office in Sardinia in Italy. It's used by more than 1 million medical professionals in the world. We sometimes jokingly say it's Berlin's most successful, completely unknown startup. We have trouble recruiting, especially engineers, because they've never heard about it. In the medical field, it's fairly well known. So 97% of German students use it to prepare for their German licensing exam. Roughly 60% of medical students in the US use it to prepare for the USMLE. Right. So just some words about myself, because this is my first time at Haystack. It's actually my first time in a technical conference in a long time. The last 5-6 years, I usually go to medical conferences, talk to our users, talk to doctors and medical students. I've started with AMBOSS 5 years ago as a product manager. Before that, I was roughly 20 years in software development. I've been doing product development for a long time, always customer-facing products. I founded a company as well, and it failed, and I shut down a company. And then for about the last 9 years or so, I work in the medical field. I came to this conference to connect with other people that work on similar problems that we are working with, namely knowledge search. So if you're in knowledge search, if you deal with search engines without transactions, if you care about evaluation of search engines and features, please say hi. I don't know too many people here, and I came here to meet some people. I'm also passionate about the intersection of software development and product management. So if you're an engineer thinking about going to product, or maybe now with vibe coding the other way around, we can also talk about this. Yeah. Cool. So the AMBOSS search engine. This is kind of a typical query. This shows some of the. So this is our real search result pages, and I just wanted to go quickly on into the anatomy of our problem, without skipping over many of the details. In general, I will do a lot of hand waving here, because I'm the product manager. So please bear with me. I can feel free to double click on anything that you find particularly interesting, and I'm happy to go into further detail. But yeah, so typical user submit a query like this: pneumonia, ABX, pregnant. What I want to know is there's a patient, a pregnant patient with pneumonia. How do I have to change my antibiotics treatment? ABX is one of the sort of so-called clinical shorthands. It's how doctors communicate. So they use the search. Then our main product is that we have these like longer articles that can be used by students to read up on, what is pneumonia, how do I do pharmacotherapy during pregnancy. But oftentimes our physician users, this is mostly for the physician use case, they actually reference AMBOSS content on the go between having a patient popping up in the EHR and on their way to that patient in these like 45 seconds on the hallway, they reference the case. So landing them on an article that might be a couple of pages, even though it's optimized for quick consumption, is not good enough. So the other thing that we pull out is a relevant deep links into entry points into the article. So clicking one of these sublinks there leads you directly to the place in the article. And then one of the newer things that we have done, blatantly copied from Google, is that we put out some direct answers if they are sufficiently specified medical questions directly onto the search result pages. And and we have so the search volume that we have, so the data volume that we have is fairly small. We have like less than 10,000 documents, 100,000 documents. We have like roughly 500,000 searches per day, so also the query volume is not super high. So some of the things that I think make our search a little bit special is that our users are expert users. They know exactly what's there. But sometimes they know the articles that we have by heart. They know if they search, they have very little tolerance for bad precision. If they search and don't find the result on rank 1, they typically blame it on themselves. So, for example, we got away from the longest time without handling spelling mistakes at all. Because even if in a giant medical word, if they had one spelling mistake, they sort of say, it's my fault, I misspelled it. This is like kind of a particular user base, I think. We don't have crazy amount of relevant documents typically per query. Like for most queries, we have like 1 to 5 relevant documents. So it's about ranking. It has to be super fast. As I said, we measure the stuff in seconds, and we want to land people into the content as quickly as possible because we are referenced on the go. And then some of the sort of special thing about the medical domain is that it's really a strange new language that people speak. So we're dealing with a lot of abbreviations. There is a lot of synonyms for things. There's these clinical shorthands, ABX, antibiotics, TX, treatment, DX, diagnosis. And yeah, spelling, our users, even though they're very efficient doctors, they sometimes misspell things as well. Yes, as I said, this is not going to be a very technical talk. I want to focus on the evaluation of our engine and how we think about to understand whether the features that we're implementing make sense for our users. So I basically have 3 topics that I'm going to talk about. First, like how do we start out with a dedicated search team? I think this is a shorter piece of the talk. Then I will talk, the majority of the time, I will talk about our journey through hybrid search, how we went about launching this in the first place and then iterating on, make it better. And then I'll talk a little bit about the our latest release, these knowledge cards, we call them our knowledge panels, on the right-hand side of the search result pages and how we think about evaluation of this. Yeah. Cool. So, so I preface this with I preface this with the conclusion. I will repeat this conclusion, so to make it stick, but just so you know what's coming. So evaluation of this stuff is difficult, right? Like in the end, we want to approximate the hidden variable. Did the user actually found what they was looking for? This hidden variable thing is something that Yuri talked about before, and I think it's really resonated with me the way to think about this. And we don't have any transactions, so people don't put anything into any basket. They're not checking out any products. So it's really hard to understand whether they found what they were looking for. It's on the go to the patient, so sometimes this might be just quickly checking up on the dosage. This is done in maybe 20 seconds. Sometimes they read up on the whole disease. It can take half an hour studying an article. Everything is fine. But so dwell time is also not a very good signal. There are many things that we use and many things that work, qualitative methods, online experiments, offline experiments. We use all of this, and they all have different strengths and weaknesses, and I want to basically lay out in a couple of concrete examples how this worked. And then one particular example I will make is to use like very simple KPIs such as click-through rate or abandonment rate, and how this can mean different things in different situations. As you've already heard, I'm not a native speaker. If I say anything that puzzles you and you think, wait a minute, please feel free to interrupt me at any point in time. Then I hope that there's some time for questions in the end. All right, sounds good? Good, let's jump into it. So one of the things that we started with was actually like really listen to your users. So as a niche search engine like this, I spent coming to company. I spent many hours just reading raw customer service tickets, and it's something that I recommend to everybody starting in a field where you're not an expert. To spend a lot of time with the users. This is an actual real screenshot from our ticketing system. So there are 16,253 tickets that contain search. I didn't read all of them, but many. And they range, like, for example, one of the good ones is here. Somebody said, okay, what is actually what did I input into the search engine? What did I expect? What did I get? There's also things like just give me a better search function, and then it's interesting to look into these users. Are they somehow special? Look into their queries. Are they somehow special queries? Look into the result sets. And back then, when I started 5 years ago, I also tried to mine this data a little bit with like natural language processing and stuff like this. And this has now gotten a lot easier, I think, with GPT. So if you just you can take these 16,000 customer support tickets and cluster them and aggregate them. But I just wanted to say this. I think it's very good to spend also a lot of time with just the raw data. Make sure you like randomize it so you don't run into the situation where you read all the tickets when the search engine was down or something like this, and then you get a little bit of a wrong view. But like I think it's very difficult to do this too much. I personally, for example, set up a bi-weekly meeting with our customer support, and then they talk to me what they hear from users, what is special, what is changing, and I talk to them about experiments we're running, so to give them a heads up, and that really worked well. And then another thing that we're doing that works fairly well is we have the sessions, we call them squirrel sessions, and we give users of our software and non-users of our software clinical vignettes. So these are like descriptions of patient cases, and ask them to research things on AMBOSS, record their screen and record their thought process and tell us what they see. And we get together as a team actually to watch these like Friday afternoon normally. We just took like 2 or 3 of these sessions in, and this really helps everybody in the team to build empathy for our user base. Right, and then also one of the things is like calling up users is the last thing I recommend to everybody. Like if you have a quirky user sending an interesting message, I have very good experience with just sort of sending them an email, here please book 20 minutes with me in the calendar, and then just have a chat with them. Oftentimes many interesting things come out of that. Right, so vector search. The history of vector search at AMBOSS was so pre-2022 we had this sort of hand-configured, massively highly tuned BM25-based search engine using Elasticsearch. I think like many companies at that time. We had tens of thousands of hand-configured synonyms, stemming, handling of Greek characters for certain enzymes and all this kind of stuff. And we saw with customer service more and more customer service tickets came in with a variation of something like I need to know exactly how it's called on AMBOSS to find it. And we looked into the query of some of these users, and one of the things we noticed was that when you talk about patient populations like pregnant patients or kids, there are many words to describe this, right? So in our platform, for example, we have an article called "Pneumonia in Children." But then a query that would match for this would be kids pneumonia. But kids and children are not the same thing, not the same word. And then babies, juveniles, kids of patients 5 years of age, like, and so this we had a hypothesis that vectors could help here, and in 2022 we started to just play around with embedding models to see if the cosine similarity between vector representations of these different concepts look like there's something there, and this somehow evolved during 2022. And in 2023, these experiments were ready to ship as an upgrade to our search engine that supported a semantic lookup of information. And then 2024, we actually overhauled this initial release that was called based on something called ZapBERT. Has anyone heard about that before? It's a highly tuned BERT model for the medical domain. And we were just sort of reading out papers, not really having any concrete experience, and also we didn't want to spend 2 years evaluating this kind of stuff. So we basically hypothesized, like many people in medicine think that highly tuned models are better than general models. So based on theory and experimentation and like unsystematic experimentation, we figured, okay, ZapBERT is the one. We launched an initial version with that, and then later we actually systematically evaluated embedding models. And I'm talking about the latest, the two things in the end here now. So relevance judgments. We started out in 2022 for offline. So when you want to launch something like this in production, you want to know whether your results become more relevant, right? So the easiest way to do this is that you have these judgment collections, and then you calculate different metrics on top of this. Daniel talked about this a little bit yesterday. I'm not going to go to the details here, but initially we started off with like 450 queries that we sampled from our query distribution, head, torso, tail, and then collected roughly 5,000 relevance judgments by domain subject matter experts, so medical doctors. They rated basically the top 10 results, whether they were relevant or not. And this gave us a great baseline to get started with. And it gave us a systematic approach to actually talk about search quality, which wasn't there in the beginning. So that was really, really good. But we also saw that these human ratings, they also have problems. So I think the biggest one that we uncovered is that these actually not, like the expectation is that subject matter expert collected ratings are very high quality. And I think, so in our experience, that wasn't necessarily true. Like there was huge discrepancy between different raters, how they grade. Like some people were, slightly rated documents were good enough, and then some people were really focusing on precision, so only one relevant document per query. So it wasn't very comparable, this kind of stuff. And then, so we had then when this part of AI-powered search, chapter 11 was written by Doug, we saw that, and we actually changed our approach to go to implicit judgments based on user clicks. We're using, I don't know if it's interesting for you, the details, but like we're using this simplified dynamic Bayesian network approach for that. The basic idea is that you look through the list of queries, of results, and then if a user clicks a result on rank 3, then you assume that rank 1 and 2 have been seen and were not relevant, and result 3 was relevant. And then from this, you calculate judgment scores. And this worked good, but if you want to release something like vector search, there's a big problem. It's called presentation bias. So users have no idea, like I have no possibility to click on it, or usually don't click on rank 60 for a query, right? Our users, if it's on rank 5, they would actually reformulate the query to get it on rank 1. So this is a plot of our NDCG over time of these query sets. We have a couple of more. I'll not go into the details now, but the problem is like at any point of time, you don't know the future, right? So we are here and we're wondering like, yeah, okay, so the metrics go down. Should we launch it? And I think this is a fair, also, this I think a fairly typical problem that is oftentimes like a little bit hand waved away by people getting that really want to get started on vector search, right? We thought, okay, let's turn to A/B testing. So we launched an online controlled experiment with this tool. I don't know if you use that. It's called Growthbook. It's a fantastic little open source thing that really changed the way that we do online controlled experiments at AMBOSS. And to understand whether whether our results improved, we looked at click-through rate. So if people are searching, are they clicking the results more? And we found that there was a significant uplift on the click-through rate. It was even bigger if we looked at the non-top queries. And I think, if I remember correctly, non-top meant in this case, more than rank 10,000 plus in our data. So just sort of the tail stuff. So we saw that users in the group with semantic search clicked more, and basically we said, okay, looks good, let's ship it. And fair enough, over time, so time does its thing. Over time, the metrics went up. So here, this is the point in time that I just showed you, where you don't know the future, but like of course, looking back, we can see that some of our query sets were impacted, and then over time, presentation bias went out of the data with relevant results receiving clicks. And then we had.
Would you say the numbers on the left are comparable to the numbers on the right?
Yeah, I mean, of course, without error bars, it's really hard to say. So it's a very good question.
It seems that some of them actually remained worse at the end than they were at the beginning.
Yeah. I mean, it's, this is like depending on the exact data set. These are also, this can be very small or very specific. So actually the most relevant ones, the big ones are the red, blue, and the red, green, and the red and the two green data sets. So these are like 1,000 queries each. The other ones are like, I think the manual one, the one at the bottom, just has like hard queries that were reported by our users or other people. So yeah, this is I think so I guess the main point is like there are numbers, but you can't like I think interpreting these numbers is still very, very important. It's a very good point. Thanks. Yeah, so and then I said before, we started off with just Zapbert, the Zapbert model, and when we've seen that okay, there is something here, we actually thought okay, it's probably not the right approach to read a little bit the literature and then just choose any model. It probably makes sense to experiment, right? So, what's the best embedding model for my problem? Who of you is using embedding models in production? Nice. Who has found the perfect embedding model for their system? Yeah. Right. So how do you do that? We started with Zapbert, which is optimized for biomedical entity recognition, and the medical field believes that this is the right approach. And then, of course, you could go to this, the MTAP, Massive Text Embedding Benchmark from Hugging Face, and they publish the best model. In my experience, so does everybody know what an embedding model is? Roughly? Yeah, okay, good. So in my experience, this is not a very good thing to do. There might be many reasons. I think there's just so much like monetary upside in overfitting on the evaluation data that this is like not really representative for maybe production use. And there's also this discussion about in-domain, out-of-domain performance of these models. So I would not recommend going to MTAP, choose the model on top one, and then roll with that. So I wanted to share what we did, and I don't know if this is particularly clever. But it worked. I think it works quite well, and I think many companies should do something like that. So we actually generated a data set that's representative of the search problem we have, right? So there's queries in different forms and languages. So first one is a question query. The second one is a keyword query. Then there's documents in different shapes. So the first one is just the title of an article. The last one is like a document passage. And then since we generated this data, and I'm happy to later talk about a little bit how we generated that, but I think it's not what I want to talk about here. Since we generated the data, we know that the query and the document, they belong together, right? So the similarity score of a good embedding model should be high. And then for the others, we know that for any other document, for every other query in that data set, for every other document but the one in the same bracket, the similarity should be low. And then we evaluated this by basically doing implementing different models and then plot the similarity scores. And you can see the blue distribution is the similarity score of the non-matching query and document pairs, and the red distribution is the similarity scores between the matching document pairs. And an ideal embedding model for our domain would have two completely separate distributions, right? So we could have like a nice line in the middle and say, okay, this belongs together and this doesn't belong together. So this is the performance of Seggern, and then this one is the performance of the best model that we have found, which is the OpenAI API one. I mean, if you're using this, you can spend a lot of time evaluating, but you could also just use that. I think that's what most people do. And then we tried out a lot of different models, and we found this is basically the leaderboard for embedding models in our domain. So if you build a search engine for medical data, OpenAI works fairly well in language, and the winner of the cross-language one, where you retrieve queries and documents in different languages, is Algolia. Yeah. Cool. And then the Seggern model that we chose in the beginning is not very good. And it's a kind of a common pattern, like the specific medical domain embedding models are kind of low ranking, and the bigger general models are actually better. Cool. Is this so? Am I happy? Have we found the perfect embedding model? No. Of course, picking the right embedding model is much more than the quality of the vectors that come out of it. Particularly around latency. Price is more like a theoretical one. For us, it's negligible. Reliability is another big one. Some of these models can be hosted on your own hardware or in your own cloud. Sometimes you can only use APIs to get to the embeddings. And then OpenAI in particular, it's good quality, but when the US wakes up, the service gets slow. Yeah. Cool. So this was everything I wanted to say about this vector search introduction. So just as a recap, because I think in the talk I promised a framework for this kind of, which is a little bit of an exaggeration, but for this particular thing. So we did qualitative insights, qualitative research that led to the ideation and the start of the development. We launched the first version with an A/B test, online evaluation to see if there's anything there, if we actually improve something for our users. And then we followed this up with offline evaluation to actually tune the parameters and improve how we actually solve the problem. Cool. Is this relevant, interesting to you? I hope. Okay, good. Sorry, it's very hard to see anyone, and I feel like I'm okay. Cool. So the second thing I wanted to talk about is knowledge panels. So the knowledge panels are this feature where we extract some pieces of the articles onto the search result pages. So for instance, so we always try to minimize time to knowledge. This is like the KPI that we basically identified that we built the sort of business case for our search team on, and we thought, okay, how can we actually make time to knowledge even shorter? And then from some users we have heard something along the lines of like, hey, sometimes I don't need the whole article, I just need the fact. And also shadowing users, we saw that in like stressful situations they just put whatever into the Chrome search bar, press enter, take the result that is extracted on the search result page and then roll with it. So we thought, okay, can we do anything here? And we came up with that. So we basically take this snippet that you see in the article here on the right-hand side. So the question is, I suspect a lung cancer. I want to do imaging. Should I do chest X-ray or CT? And so the answer can be extracted on the search result page there without and give users a much more focused, succinct answer without scrolling, without the visual burden of like having all the article around it. And then this time I will start with the offline part, because for this feature we're really concerned about it's a medical thing. Like doctors use this, read the information and then go treat patients. So it was really critical to understand, are these panels actually good? And I wanted to share a little bit about the process, how we've done this. So it started with somebody wanting to try cursor, and we had this problem, and he said, yeah, I'll just see how far I get in half a day. So this guy's called Matteo. Matteo basically vibe coded this tool together here on the right hand side that would give our colleagues, medical doctors, the option to rate these knowledge cards on a scale of, is it comprehensive? Is it in line with our article? And does it have scientific accuracy? And then we rolled it out, and it's nice. There's more than 100 employed doctors on staff at AMBOSS, so it's very, very easy to basically roll this out and say like, hey, come on, can you please all spend 15 minutes rating 3-4 of these cards? And then you have, after a day, you have a turnaround time, and you have, I don't know, 200, 400 labels. And then we use this gold data set to actually tune a prompt that would do the same thing. As the doctors were doing, and I think there's something new coming out with these with the way that prompts and classical software engineering interlaps, where the process was that we really co-developed this with the medical doctor. So we didn't give them much instructions. They came up with categories and criteria, when to rate what, and then we just interviewed them. So when is something 3 on fidelity? And then they said some things, and we just wrote this into the prompt. It was the start of it. And then we did this prompt engineering thing. But to make it a little bit more engineering-like, we now had a gold standard data set, and when we optimized by basically calculating inter-rater reliability, something that Eric talked about yesterday as well. And there's many ways to do this. We chose this Cohen's-Kappa coefficient. Is nice because it gives you an intuition of what the number means. So if you do mean squared error or something like that, then you just have a number, and it's really kind of difficult to understand whether it's now a good rater or not. But Cohen's-Kappa has, like, in the linked paper, there's actually a table that tells you, like, if it's 0.8, then it means the rater is good. So it helps with like communicating the results. Yeah, and then we basically put this. I mean, this is just a screenshot. We of course put this into code, but you can imagine it like this. So we have this prompt here on the left hand side where we say what a knowledge panel is and what the criterias are and how this works. And then on the right hand side we put in the different knowledge cards, and suddenly we have something that basically rates online how good this is. And then you can improve the prompt and you can improve the rater by doing this classical stuff like error analysis. You can look into where the rater and the humans disagree, and then you can look into individual case, and then maybe you're missing a criteria, or then you discuss this with a subject matter expert and you basically record what they say and then think about, okay, should I make a rule about this? Do I need to shorten my prompt? Do I need to add an example here? And you try all this kind of stuff. But of course, you need to do the good practices from machine learning still. So, for example, avoid overfitting. Of course, you run the risk that you then overfit your prompt to the kind of examples you have. And then the way to do this is using a holdout set or cross-validation. So these kind of things you still, of course, have to do. But for us, this worked fairly well to have a process that would continuously evaluate in an offline fashion whether our generation prompt works and does something good. And I think Doug is going to talk about this next. There is something happening here where we have a generator prompt and a rater prompt that can rate the generator. So there's a potential to have these agentic loops to improve the product. And we've tried a couple of things. We've also tried to create fine-tuning data set to distill larger, more expensive and slower models into smaller ones. Nothing really worked so far, but I think the writings are on the wall that this is something new, very cheap, very fast turnaround labels in a very high quantity. Somebody will figure out, maybe one of you, how to use this to really self-improve search. Make the what's it called? Search. What's it called? The word where the AI optimizes itself. You know what I mean? Yeah. Anyways, cool. But now we've done this, so we still don't know whether the knowledge panels actually solve a user problem, right? So this time we did an online experiment again. And tried to do the exact opposite. So where we last time tried to improve click-through rate, this time we try to increase abandonment rate. So people searching something and then not following up. And we assumed, and there's of course many problems with this, that if you don't click anywhere, you will have found what you were looking for. There's some data. So some users move their mouse to where they read. So we track that. And we can see that for the people that move their mouse to the area where this information is, the abandonment rate is significantly higher. So there's some indications that there's something there. On our mobile app, we have much more screen real estate, much less screen real estate. So it's an interaction where you just tease the content and you have to expand. So there's more high quality signal there. But then the use case are not the same. So I don't know, there's many, again here, we get some data, we get some numbers, but they're not self-explanatory. They're not the one magic thing that you just know, okay, now I have to improve this. Cool. So the summary here again, and this is where I'm getting with this framework thing. We kind of did the same thing again. So qualitative insights led to the identification of the opportunity and start of the development. An online evaluation told us if we can, or we assume that we actually have solved the problem, that we can roll out to users. And then with offline evaluation, we again tune parameters, improve, or we solve the problem. So this is it. I don't have anything more. But just to repeat, I would always recommend to anyone, also to engineers, but especially to product managers, spend a lot of time with unscalable stuff, talking to users, reading individual support tickets, watch individual users use your platform. look at raw query logs, look at raw result lists together with a domain expert, and then a lot of the ideation that we are doing comes from that. A great search is relevant and also has great UX. So I think this and so online and offline experiments have to always, I think, be move together. When we've started A/B testing in our company, it's not traditionally an A/B testing company. So this culture change, when we started to actually formulate hypotheses and launch tests, have really changed the way we think about launching features. Really made a huge difference to the, I would say, level that we work. Yeah, and then lastly, so there is something with GPT provided judgments. I'm very curious to see what happens next. And then lastly, my team sent me here. I'm here alone. My team sent me here. I have not done all this work. I have this amazing team, and it's interesting. Actually, my biggest surprise was that in the 2 keynotes today in the morning, both René and Rick doubled down on this point of having diverse viewpoints is ever increasingly important. And I can just completely agree to this. So here you can see nearly all of our team. 2 people are missing. So there are some developers. There's 1 data scientist, 1 data engineer, there's a designer, and 3 medical doctors. 2 of them have double degrees in computer science. 1 doesn't. And they just work together. We just work together as one team, and this I think it's invaluable. And with the move of where software is moving also into prompting, it's getting ever more important, because the medical doctor, we just hired her into our team a couple of months ago and just said, okay, we didn't really have a job title for her, because there are software engineers usually have some sort of technical background, can code or something like that. But she joined the team as a software developer without using a programming language. And she's contributing crazy, because the only way that she can unfold impact is by pairing up with one of the developers. So it has a crazy effect of creating this domain awareness in our whole team. And then, of course, when it comes to doing all this prompt stuff, it's just perfect if you have a complete domain expert doing this sort of stuff. So yeah, thank you very much. This is all I wanted to talk to you about, and I hope there's some time for questions. Yeah.
Thank you, Valentin.
Thank you.
Do we have questions in the audience? Yeah.
Just go here so I see it.
Hi, great talk. Early in the talk, you talked about HRT and the human evaluations perhaps being questionable. But then later on, you said you created a solution for doctors to give you feedback.
Yes.
Were there any particular techniques that you used to get more valuable feedback from people?
Yes, it's a very good question. Yes and no. So yes, we have actually had the same dataset label, have multiple people label the same dataset, and use the average as gold standard. And no, because an average between 2 subjective numbers is still not a good gold standard. I think there is no good. I mean, well, maybe there is a good way. I don't know, but this is just a hard problem, I think. And there's probably, creating criteria together. One thing that we tried that also worked well is discussing the results where they disagree together in a group and then have them rejudge. But this, of course, is super expensive. So we tried many of these things, but in the end, I think we have a kind of a small team. So we can't really nerd out on each of these topics: embedding model evaluation, finding good judgment lists, creating implicit judgment lists. Each of them can easily, a team can spend a year on. We usually do the stuff good enough and then move on. Yeah. Sorry, there's no good. No. Yeah. 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 Yeah.
Hi there. You mentioned time to knowledge as a primary KPI.
Yeah.
Can you unpack that? Tell me how you defined knowledge and how do you know that the knowledge was actually achieved?
Yeah. I mean, so yesterday there was this product manager meetup, and I shared my regrets with that metric. So it's hard, right? So we don't know whether you actually found what you were looking for in the end. There is no hard truth. There is approximations, and we spend a lot of time trying to understand from behavioral data whether people did find what they were looking for. We tried asking them with like in-product questionnaires. None of this has really worked out, and I would say this time to knowledge metric, as far as I'm concerned, I'm more using it these days for like outward-facing communication. So when I talk to the senior leadership of the company, my stakeholders, this is something that they can get behind. It's also something that, you know, resonates with our customers, with sales as well, marketing. With us moving more to an experimentation driven culture, also for online experiments, what we actually are doing and using in day-to-day work is the opposite, like the simplest possible metrics. Did users click or did they not click? This works fantastically. But of course, very hard to communicate, right? Like in a subscription business, the line from this click to the user churning or not churning is very long. And also there, I don't have a good answer. I think it's a hard problem. And time to knowledge is great communication tool and not so great to actually operate on.
Okay, thank you. We are at time, so let's thank the speaker again.
Thanks.
And if you have any more questions, I think you can directly contact Valentin. We have a short break, 15 minutes, and then we continue with Doug here in this room.